Okay, this is help with the Hooke's Law activity. So what we did is we selected different masses from 100 grams, 150, 200, 250, and 300. You'll note that we had to convert those over into kilograms. And what we did on the simulation was we took the mass, we set our spring constant to a certain value. You'll notice that changes the spring. So if you're just at a table near the front of the room, pick one of these. If you're at a table more towards the back, pick one of these. I used this one in my particular data. So I grabbed the 100 gram mass and I put it on to my spring, and I moved over here and I measured the displacement. So I measured this green arrow. That shows how far the spring has stretched from where it started. So we did that and got a number about 8 centimeters or so. And then you'll notice I converted that into meters. Now the other thing we have to recognize is it's not the mass that stretches the spring, it's actually the weight of that mass on the end. So in order to calculate the force, I'm going to type equals, that does a calculation, and then I'm going to click on cell A12 and multiply by 9.8. Now we could use 10, but since this is a lab, I'm trying to be a little more specific. And then I get that particular number. I'm going to X out of this just so I can show you how to do it yourself. As long as this cell says this equals A12 times 9.8, I can grab this little corner box and fill down, and it will take the number over here, that particular mass, and multiply 9.8. So now we have the force acting on the spring, which is in fact the weight is the particular force. So now I'm going to go through how to make the graph. So start by clicking anywhere that is not on an actual piece of data. So click in an empty square anywhere. Go to Insert and Chart. You're going to slide your chart so that you can see your data. And first thing we do is change this to a scatter plot. Next thing you're going to want to do is add the x-axis. I'm asking you to put displacement on the x-axis. So you click Add x-axis, and you're going to highlight cells A12 to A6, or I'm sorry, C12 to C16. If you prefer, you could literally just type in C12 colon C16 like that, if that's easier for you. Then you come down to Add Series, click on this little 4 square button, and the series is the y-axis. I would like force on the y-axis. So I'm highlighting my numbers. Again, you could just type the B12 to B16 part. And at this point, you should have a graph. The numbers on this axis should go 1, 2, 3, and then you should have your displacement numbers kind of representing this on this axis. So now we're going to head over to Customize, and you're going to go to Chart and Axis Titles. The chart title, you do not get to be creative. It is always what's on the y-axis versus what's on the x-axis. And our y-axis is force. You don't need units in the title. And then versus the x-axis is displacement. Then you're going to change chart title to horizontal axis title. The horizontal axis is displacement. But on the axes, we do put units, and we did convert those displacements from centimeters to meters. Your vertical axis is force, which happens to be the weight of the object, but we're just more generically calling it force. And the unit for that is newtons. So that's what your titles and labels should always look like. Next thing we want to do is get the equation for the line of best fit. We can see that this data is linear, so I would like to know what's the equation of the line that best goes through those points. So you come down here to Series, and a couple things you have to do. First, you're going to click on Trend Line. Next thing you're going to do is click on Label, because right now I see the line, but it doesn't tell me what the equation is, so click on Label and click Use Equation. And at this point, you have the equation of your line. This number right here is the y-intercept. It should be very close to 0 if we were to extend that graph. That's because no force goes with no displacement, so the graph should go pretty close to 0, 0. And this number right here is your spring constant. My spring constant happens to be 11.1. It's a pretty tight spring from the simulation. That means it would take 11.1 newtons for this particular spring to stretch a full meter. So if you had 5 in front of the x, that means it would take your spring 5 newtons to stretch 1 meter. So the bigger this number, the harder it is to stretch. The only other thing we did on the analysis was indicated that the data is linear. Basically what that will tell us as we start to learn more about physics is that if we double the displacement, like from point 1 to point 2, it should double the amount of force that's required. If I were to triple the displacement from like point 1 to point 3, so if I pull 3 times farther, it ought to triple the amount of force that's required. So the fact that it's linear data tells us all that information. One thing to note, if you ever need to go back in to edit your chart after you've made it, click these 3 little dots and go to edit chart, and then you can get back in to edit whatever it is you need to edit.